Okay. So you write it down first point or dry tower intake. In dry tower intake, water is directly enters the withdrawal conduct from reservoir. Okay? Or you can directly write tunnel also. It's up to you. Okay? Directly enters to the tunnel from reservoir. In dry tower intake, water is directly enters to the tunnel from reservoir. Second point you write. Second point you write. Dry tower intake is preferred when fluctuation in reservoir level is less. Okay? So anyways, there will be some fluctuation in the reservoir when there is coming the discharges every interval of time. There are our discharge is changing in the river. Okay, if it is an unsteady flow, so if there is an unsteady flow, definitely there will be some fluctuation. Okay, so if the fluctuation is less, then we can go for dry tower intake. The advantage is it requires less construction cost. Okay, as compared to wet tower intake. If the fluctuation is very high and it occurs very often, so we don't have any option. We have to go with wet tower intake. Okay. So your second point you can write dry tower intake is preferred when fluctuation in reservoir level is less. Okay. Then third point you write waves in water level, waves in water level and floating debris, etc., are comparatively less. Over. And the last point is that construction cost. Okay, construction cost of dry tower intake is much less than wet tower intake. That is the last one. Okay, over.
Yes, sir.
Okay, okay. So we move on to our next intake steps. Okay, so till now we have discussed runoff river intake structure, then canal intake structure. Okay, So very basics one is our runoff river intake structure. Okay. Then if that river contains lots of silt or sediment, then you have to go for canal intake structure. Okay. Then then we have dam intake structure. So when we use dam intake structure, when we start storing the water. In first two case, we are not going to store water, only we are going to divert the water. Okay. So when we store the water, that means when we construct a reservoir, then the dam intake structure connected to the reservoir or dam. Okay. So then again in that dam intake structure, we have two types. One is dry tower intake, one is wet tower intake. Okay. So dry tower intake, when the fluctuation level or floating materials are comparatively less, then we can go for dry tower intake, or else we have to go for wet tower intake. If the fluctuation in the reservoir is quite often occurred quite often, so and in that case we have to go for wet tower intake. Okay, and then we have some more intake structure which nowadays we don't use this kind of intake structure, but still it's in your syllabus we are discussing. Okay, so next you write simple submerged intake, because this intake structure have lots of disadvantage. Okay, anyways it's still in your syllabus, so we are discussing. Okay, simple submerged intake. Next one. So kindly you draw the structure. Okay, this is here we have bar screen this time. Okay, here we have bar screen. Okay, and this is our tunnel. This is our concrete block. So this is at the bottom of the reservoir. Okay, I think that term itself we have understood, submerged. So it's underwater. Okay, this is here. It's written cast iron lining. Cast iron lining. Okay, this is your tunnel. This is two powerhouse. This is your concrete block, and this is your reservoir. Okay, it's at the bottom of the reservoir. This is the level of reservoir.
Sir, what is the top part below the reservoir level?
Or this is bar screen, like dress rack. Okay, or you can write bar screen. Means it's a screen just to screen those floating materials to avoid entering into the tunnel. Okay, same function as dress rack. Override. Okay. So these are this see drawbacks is in beneath the reservoir. Okay, so when definitely we all know that river contains sediments, and at due course of time it deposited at the bottom of the reservoir. So okay, so when it deposited it may covered the whole this index structure. Okay, so these are disadvantages. Okay, but the advantages is it requires low cost. Okay, so nowadays we don't use all this simple summer structure. Anyways, we can use for a minor project where at a very uh, high elevation where your sediment content is very less. Okay, so in those river we can still use in some cases. Okay, but it's very rare. Okay, nowadays we always go for dry because whenever we design a dam or hydropower scheme, nowadays we design for multi-purpose, not for a single purpose. Okay, so when we go for a multi-purpose, then this capacity or of that particular reservoir or product project is very high when you go for multi-purpose. So in that case, we go for dry tower intake or wet tower intake. Okay, and whenever we have the small hydropower plant, then we prefer for canal intake if the sediment is more, or else we go for runoff river intake structure. Okay, this we are very old now. It's like very rarely it's used. Okay, till you write the first point. Simple submerged intake used in small hydropower plant. Okay. Second point you write. It is used in the reservoir or river which does not contain lots of sediment, so that the intake may not get buried in due course of time. Okay. Third point you can write. It is economical and widely used in small power plant. And another disadvantage is that they are not easily accessible for requirement. Okay. If there is any maintenance required, then it's very difficult because it's beneath the reservoir. There is another disadvantage. over. Okay, so we move on to our next one. Okay? That's soft intake. Kindly draw the structure. This is also beneath the reservoir. Okay, this is the reservoir level. Okay? Over. So you write it down. First point, components. Okay. First you write we have trace rack at entry of water to the shaft. You can see here in diagram. Okay. Here we have intake structure. Sorry, trace rack. Okay. Here we have trace rack. The diagram is not properly visible. I'll try in the next class to give you a proper diagram. Okay. So do one thing. Now you write it down. Okay. We'll discuss in the next class. Okay. Now that the diagram is not properly visible. First point you write trace rack at entry of water to the shaft. Okay. Second you write vertical or near vertical shaft followed by an elbow. Okay. You have seen in the diagram it's like this. Okay. So it's like an elbow which connects the shaft and penstock pipe. That elbow portion connects the shaft and the penstock pipe. Okay. Then we have gate arrangement, gate chamber, hoist chamber where we have hoisting cables to operate the gates. Okay. Hoist chamber is the chamber where we have hoisting cables and we control the gates from that chamber. And the last point you write, it is a vertical shaft. It is a vertical shaft driven in the bed which carries water to the penstock for power generation. Here also these advantages are same. Okay. If the sediment is more, it can be buried. Okay. And then it is not easily accessible for any maintenance purpose. Okay. As it is driven in the bed of the reservoir. Over. Okay. So the proper diagram I'll give you in the next class. Okay. So next topic you write trace rack. So about trace rack we have already discussed. Okay. So I have given you some notes about trace rack. Okay. Like here, what will be the spacing of the bars? Okay. So first thing that trace rack, I think you all know, it's like a screen. Okay. Where we have bars of some interval. Okay. So those interval is called spacing. Okay. The spacing of bars. So and these bars, it may be welded or bolt connection. Okay, it may be welded or bolt connection. So here we have this thing. Then we have spacing. That spacing depends on nature and size of debris. Okay, for that particular river, and also it depends on types of turbine used in powerhouse and its size and space. Okay, so these are the two factors depends on which we provide the spacing of the bars of dress rack. Okay, so here are giving some values also for spacing for high discharge and low head Kaplan turbine. Spacing may be 25 centimeter. Okay, for Francis turbine, spacing is equal to the distance between the runner vanes. Okay, so what is runner vanes? Don't worry, we will discuss again. We have a chapter called turbines. Okay, what is runner vanes? We'll discuss there. Okay, so for Kaplan turbine, maybe around 25 centimeter, or for Francis turbine, it is equal to the distance between the two runner vanes. Okay. These things, I think you can take a screenshot. Okay, apart from writing. Very simple things. One is stress track, then we have spacing of bars, then we have pressure. What are the pressure? It acts on the racks. So first one we have dead weight of the assembly. That means the dead weight of the truss rack, whole truss rack. Okay. Okay. Second is water pressure. Then dynamic pressure of floating materials. Okay. And then four is unbalanced load due to partial or total clogging of the racks. When the plastic bags and all is coming in and it's attached to the racks, then it reduces the space, okay, or flowing area. Okay, so this is another load which acts on racks. Okay. Then I think we have velocity, cleaning of racks, okay, and design velocity. Okay, so this part I'll give you, okay, as a notes. You just read once, okay, and if you have any doubts, then we can discuss later on. Okay, so you write next topic, gates and valves. Okay, that trash track portion I'll share with the seer. Okay, he or she will circulate among yourself. Okay, so don't worry. You write gates and valves. So we have different types of gates. First one is vertical lift gate. Second is roller gate. This is your radial gate, and fourth one is cylindrical gate. In this type of gate, you have already used. You have written there for dry tower intake. Number four, and out of this, we mostly or frequently use vertical gates. Are most frequently adopted for intakes. Over. And next is your valves. Okay. Gates we have already discussed. Now is valves. Valves we have various types of valves. Okay. You can write it down. Okay. We have one seven valve. Okay. Butterfly valves. This is like a spherical valve, fishtail, needle valve, air inlet valve. Okay.
Sir, what's that sixth one, sir? PL.
It's plunger. Or fifth one, tube.
Sixth one, sir. Sixth one.
Sixth one, plunger. And last one is air inlet. Okay. Over.
Yes, sir.
Okay. So then we move on to the next classification of valves or gates based on function first. Okay. Classification of valves or gates. Number one, based on function. Previously, whatever we wrote, those are different types. Okay. Those plunger, tube, pistil, that valve looks like pistil. Okay. So that's why it's called pistil. And there are different function also. So I think this is not that much required for you guys. Okay. Just but you should know what are the valves is available for this hydropower. Okay. So next you write based on function. Number one, regulating valve. Number two, open and shut valve. And number C or third one, this energy dissipator valves.
Say again the third one, energy.
Dissipator valve. Okay. Then you write next one is based on location. This is your terminal valves, penstock valves, turbine valves, and guard valves. Over. Okay. So this chapter is almost over. Okay. Last topic is there. One is canal. Okay. So the canal portion we are not going to discuss. Okay, because you have already studied about canal in previous semester in irrigation. Okay, irrigation. So this is your self study. Okay. So what we have to study here in canal section, what is canal everyone knows. Okay. Next one we have to study, kindly write it down. Okay. Lining of canal. Those things is already there. You have studied. Okay. Very simple. And after that also if you think that we need to discuss, then we will discuss at the end. Okay. Just remind me. Okay. So first you write lining of canal. Okay. Lining of canal. Second is maintenance of canal. And third is losses of canal. And fourth is classification. Okay. These are the four things you have to study of your own. One is because these things you have already studied in previous semester. Lining of canal, maintenance of canal, loss of canal, and fourth one is classification. Clear?
Yes, sir.
Okay. So I think tomorrow you have your exam, I think, na? Tomorrow, first sessional exam we
Yes,
have, I
sir.
think.
Yes,
Okay,
sir.
then we will start with the next unit in the after exam. Okay, I think next week after exam means tomorrow is Wednesday, yeah? Tomorrow is
Yes,
Yes, sir.
sir.
Next week, sir.
Thursday, Friday. Okay, yes, next week. Okay, next Tuesday. Okay, so we'll start with search tank. Okay, next is also a small chapter. That unit is also not that long, but we have derivation. Okay, we have derivation.
Okay.
Then we move on to our turbine chapter where we have lots of numericals and derivation. Okay, so thank you students. We are going to end this meeting. Okay, because it's already time. Few seconds left. Okay,
Sir, will you
thank
Okay.
you.
share this PDF note, sir?
I'll share only test track because this video I'm going to upload in ERP. Okay, you can anytime you can check it out.
Sir, because I missed some previous classes after the
Those
earthquake.
videos are also we
Yes,
are
sir.
going to upload. Okay, it takes some time,
Okay,
but
sir.
we are going to upload all the videos. Means all the classes. Okay, what we have to we have already recorded all the classes and we are going to upload all the